Hi, everybody, and welcome back to Module 4, Task 1. And today we have two learning targets that we're going to be working on. The first learning target today is I can create an expression to model a situation. So we're going to be creating expressions today. And the second learning target that we're going to be working on is I can apply properties of operations, so add, subtract, multiply, and divide, in order to determine equivalence, which means in order to decide if two expressions are equivalent or not. Now, you may notice that some of what we're doing today is a bit of a review of something we've done before. Today, we're just going to be extending our understanding so that we can kind of go a little bit deeper into some of these ideas. Let's start by just reviewing what a mathematical expression is. A mathematical expression is a representation made using numbers and variables. Now, one of the keys here is that a mathematical expression does not have an equal sign in it. So if there is an equal sign, then we have an equation, and that's sort of a different thing altogether. When we're talking about expressions, we're looking at expressions that do not have an equal sign. An example of a mathematical expression would be something like this: 2 parentheses x minus 6 plus 7. You can see here we've got numbers, variables, and symbols, and there's no equal sign. An example of a non-expression, so something that is not an expression, we call that a non-example, would be something like this: 3x plus 7 equals 24. Because of this equal sign right here, this is not an expression, this is an equation. What we're going to be asked to do today for our first learning target is to create expressions, and we're going to create these expressions by following directions that are written in words. So here's an example of what that's going to look like. You are going to be asked to read the words here and use those words to interpret the mathematical or symbolic representation. For example, number of students that bought pizzas, we're going to call that X. Now, the second one says, after the second week, the number of students that bought pizzas increased by 10. The key here is to start by identifying the mathematical vocabulary. And in this sentence, we're talking about increased by 10. What that means is we're going to take the amount that we previously had, which we're calling X, and we're going to increase by 10. Increase by 10 means plus 10. So next to the X, I'm going to write plus 10. The next step here says after the third week, the number of students who bought pizzas tripled. Now, mathematically, the word tripled means multiply by 3. So what we need to do is show that we're taking exactly what we had before, the x plus 10, and multiplying by 3. To do that, I'm going to copy down the x plus 10. And then to show that I'm multiplying that entire expression by 3, I'm going to put a parentheses around it with a 3 on the outside. And that shows that I'm multiplying that whole thing by 3. Last but not least, the fourth step here says in week number 4, the number of students who bought pizzas decreased by 9. Now, the phrase decreased by 9 means subtract. So this means take whatever you had before and just subtract 9. So I'm going to copy down exactly what was already there, 3 parentheses x plus 10. And at the end, I'm going to put minus 9 to show I'm subtracting 9 from the whole thing. This down here at the end is our final expression that we created, and that sort of is your goal, is to create that expression. Now, once we have an expression, one of the things that we're going to be asked to do is determine if that expression is equivalent to another expression. So, since there are lots of different ways to write the same thing, at the end we want to know, are these the same or are they not? There are 3 different simplification techniques that you can use in order to determine if expressions are equivalent. The first technique is distributing, and we've learned distributing before. So this is a little bit of a review of something we've already talked about this year. When we distribute, we are passing out the number that's on the outside of the parentheses to everything that's on the inside. So if we multiply 3 times x, we get 3x. And if we multiply 3 times -4, we get -12. The biggest issue here tends to be really making sure we're paying attention to the signs, which means positives or negatives, and that way we don't make a mistake in our arithmetic. The second technique we've already learned this year is combining like terms. Now, combining like terms means putting terms together that have the same variables or lack of variables. So an example would be in this expression, the 4x plus the 5x. When we combine those together, they make 9x because 4 plus 5 is 9. Now, in addition to that, in this expression, we could also combine the -7 and the +2. -7 plus 2 would be -5. So I'm going to write -5 because of that negative, and then that's my simplified expression, would be 9x minus 5. Now, the new technique that we're going to learn today is the idea of dividing. So we've seen things like this, expressions like this, as one side of an equation before, but how do we simplify this if instead of solving, we are just simplifying? The answer is we need to learn how to divide when we have these kind of complex fractions. When you have a fraction where there's 2 terms at the top and only a 5 at the bottom, we're going to break this up into 2 separate division problems. First, we're going to divide the 15x and the 5. So I'm going to write that down. 15x divided by 5. Separately, we're going to divide the -20 divided by 5. So I'm going to write minus because of that negative, and then 20 divided by 5. So what I'm doing here is I'm taking what's one big fraction and just breaking it up into 2 separate division problems. Then I'm going to divide them each separately. So 15x divided by 5, 15 divided by 5 would just be 3x, and 20 divided by 5 would be 4. So my simplified expression would be 3x minus 4. Let's try that one more time because this is a new thing, so I just want to make sure we've really got it. So dividing for this next problem, if I break this up into 2 separate division problems, the first one is going to be -18x divided by -2. And the second division problem here is going to be positive, so I'm going to put a plus 20 divided by -2. Now I'm going to simplify each of these division problems separately. So -18 divided by -2 is going to make positive 9x, because when we divide a negative and another negative, we get a positive. Then if I do 20 divided by -2, I get -10. So instead of putting a plus here, I'm going to put minus because my answer is -10. Now, how are we going to be asked to use these simplification techniques? One way that we're going to be asked to use this is that if we want to determine whether 2 expressions are equivalent, what we're going to need to do is simplify those expressions as much as possible and then compare the results and see, are the results the same here? So in this first example, we're trying to determine if this expression right here is equivalent to this expression. To do that, we're going to need to simplify. Now, in this problem, let's start with this first expression. What I'm noticing is that there is a parentheses here, and there's a minus right outside the parentheses. However, there is no number there. So what I like to do is draw in the number 1. One of the things that I know is that when there's no number by a minus, there's actually invisible -1. Now, based on the way that this looks, I'm going to start with distributing. So I'm going to distribute the -1 to the 2, which means I get -2a. And then I'm going to distribute the -1 to the -5, which means I get +5. Now this 13 over here is just kind of hanging out. So I'm just going to drop it down and not change it. And then I'm going to start to simplify after that. After that, I'm going to look for combining like terms. Now in this problem, the like terms would be the 13 and the +5. When I combine those, I get 18. The 2a here, the -2a, doesn't have any like terms because nobody else here has an a, so I'm just going to drop it down. Now let's look at our second expression. This first expression is as simplified as it can get, so that's as simple as I can make it. If I look at my second expression here, there's nothing to distribute because there's no parentheses. There are no like terms in this expression, and there is no division that I can do to simplify. So this one is also as simplified as it can get. When I compare these two expressions, what I notice is that these two expressions are the same. They're equivalent. So that means that I would circle, yes, these expressions are equivalent. Even though they didn't originally look like they were equivalent, once I simplified, I could tell they really were the same. In problem number 2, let's start with the first expression and simplify it, and then we'll simplify the second one, and then we'll look at the final answers and see if they're the same. So the first expression has a big old fraction in it, which means I'm going to use my new division technique to simplify. So I'm going to break this up and make 2 separate fractions. So I'm going to have 24b divided by 2, and then separately, I'm going to have -12 divided by 2. So I'm going to put a minus and then 12 divided by 2. Now, if I simplify these one at a time, 24 divided by 2 is 12b, and 12 divided by 2 is 6, so I'm going to put -6. And this is going to be my simplified version of my first expression. For the second expression here, if I look at it, it seems like I'm going to start by maybe distributing because there's this parentheses with a number on the outside. So if I distribute the 3, I get 12b. And then if I distribute the 3 to the -2, I get -6. Now, there are no like terms here, and there's no fractions, so there's really nothing else I can simplify. This is my simplified expression. When I compare these two results, I'm going to see that these are the same. And since they are the same, I'm going to go ahead and circle equivalent. Yes, these are the same. They are equivalent. Okay, now the next thing we're going to talk about is we're going to kind of look at equivalent expressions in a different way. Sometimes we need to create equivalent expressions. Now, to do this, we sometimes set it up as an equation. So what we're doing here is we're creating an equation by putting expression number 1 on the left side, and we're putting expression number 2 on the right side. In order to show that they're equivalent, we're just trying to make them equal to each other. So what we're really saying here is, how can we make expression number 1, which is on the left side, equal to expression number 2? Well, in order to do that, we need to make sure that the two sides of this equation are balanced. So what we're going to do is simplify the left side and simplify the right side and see if they're the same. On the left side of this equation, I'm going to combine like terms. So 5x minus 3x is going to make 2x total on the left side. And 4 minus 1 is going to make plus 3 on the left side. So that's the simplified version of the left side. Now I'm going to simplify the right side. So the like terms on the right side would be the 8 and the -5, which makes positive 3. And since the 2x does not have any terms to combine with, I'm just going to drop that down. So I get 2x. And I simplify the right side. Since these two expressions are the same, they are equivalent. They're equal. Now, here's how we're going to ask you to think about this. So, what we're going to do is give you an equation where you're missing some pieces. For example, you can see there's a blank here on the right side of the equation. You're missing that information. We want you to figure out what to fill in the blank with to make the expression on the left side equal to the expression on the right side. So we're not solving an equation here. I'm not asking you what is the value of x. I'm just asking you what is missing. The way I want you to think about this is that there's two sides. So let's simplify the left side first. On the left side of this equation, I'm going to combine the like terms. So that's going to give me 5x plus 2x makes 7x. And then there's the plus 4. That's kind of just hanging out. There's no like terms for him. Now on the right side, we can see that we have a blank and the plus 4. So what's missing? Well, the plus 4 is already the same on the left and the right. So that's already the same. That means that what we're missing on the right is the 7x. So the 7x would be what we would fill in the blank with here to make the left and the right the same. That's what we're missing to make these equivalent expressions. Let's try the second problem. So we're going to start the same way. I want you to draw a line so that you can separate the left and the right. Let's simplify what's already there. So here's what's already there. We know that on the left side, we can simplify the 7 plus the 5, and the 7 plus the 5 makes positive 12. And then we've got the 3x and the blank, and we don't know what to fill that in with yet. On the right side, there's really nothing we can simplify. I'm just going to drop down the 8x plus the blank. So what can we do here? Well, let's look at the x's first. The left side has a 3x, and the right side has an 8x. That means that we have more x's on the right than we do on the left. So in order to make these two sides equal, we need more x's over here. We're missing, if this is 3 and this is 8, we're missing 5 x's to make the x's the same. Because 3 plus 5 would give you 8. So this side of the equation is missing 5x. Now if we look at the terms without numbers, the left side has a positive 12 and the right side doesn't have any numbers. So it's missing that 12. That means that we would fill in the 12 as the missing piece on the right side. Now let's look at the last example. So in the last example, again, I want you to think about the left and the right separately. Now in this last example, we're going to handle this a little bit differently because there's really nothing to simplify right now. There's nothing here, although that would be something that I would distribute. Okay, so I'm going to distribute that number, whatever that number is. On the right side, we have the 12x and a blank. What I need to do to figure this out is ask myself, what number could I distribute so that when I distribute to the 4x, I get 12x? Since 3 times 4 is 12, the mystery number that needs to get distributed is a 3, because 3 times 4 would be 12. Now when I simplify, I get 12x minus 6, because I would distribute to the 4 and also to the negative 2. On the other side of the equation, I have 12x plus some mystery number. Now, if we compare the two sides, the 12x is already the same on the left and the right. And if we look at the other number, we have a minus 6 here, and we're missing a number here. So that missing number must have been a minus 6. Again, this is just a different way of thinking about equivalent equations. Equivalent means they're the same. So once you simplify here, the left side and the right side should be the same. And you just have to figure out the missing information that would make that happen. Thank you guys so much for watching, and I'll see you soon for some practice in class.